All right, this is a quick video about the sequence of operation for a typical gas furnace. You need to think about this ignition control module as a series of inputs that trigger outputs. The very first input that happens is we get 24 volts on the W terminal. That tells the furnace control module that we're calling for heat. The very next thing that it does is check to make sure this pressure switch is open because our inducer has not started running yet. So it wants to make sure that this pressure switch either is not jumped out or failed in the closed position. If that pressure switch is open, that's the input that it wants to see. It triggers an output. It will energize this inducer. Now that inducer will start to spin. It's going to cause this pressure switch to close. That is an input that the board is looking for. Once it receives that input, then after a few seconds of purging the bad air out of our combustion chamber with fresh air, we're going to start a trial for ignition, and that is a series of outputs. We're going to have an igniter that's going to energize first. In that case, that is a spark igniter right here. And at the same time, we're also going to energize the gas valve. Those are outputs. Now, we only have a few seconds to establish flame, or else it will drop these outputs because it does not want to be dumping raw gas that has not been lit in the combustion chamber. Now, the way that it senses that we do have a flame is this flame sensing rod that uses flame rectification to send a microamp DC signal back to the board as an input. If it has established flame, then it will continue the output to the gas valve, but it will drop the output to the igniter because the igniter no longer needs to run. The flame is self-sustaining. Now, after a little bit of a delay, we're going to then energize as an output the main blower fan. The reason why we don't energize it immediately is because we don't want to be blowing cold air on the occupant. So once the heat exchanger is warmed up for a few seconds, the blower should eventually come on. Now, throughout the heating cycle, we're also monitoring other safety switches such as high limit switches and flame rollout switches. Some of these switches are not automatic reset, they are manual reset, which requires somebody to physically push that button and investigate why it tripped. Now, once the heating cycle is complete, the thermostat is satisfied, we're going to drop this 24 volts on W, and that is a loss of an input. And the logic in the board is going to say, okay, we no longer need to heat, so I'm going to drop my output to my gas valve and stop heating. But it's going to maintain the output to the inducer because we want to do a post purge. We want to get rid of all those harmful combustion gases, get them vented on out. So this inducer will continue to run for a few seconds longer as an output from the board. Then eventually the inducer will stop. And then after that, a few seconds later after that, after we've cooled down our heat exchanger, our main blower output will also cease and we are no longer heating. Nothing is running on this furnace. Now let's see it in action. We're going to call for heat, and the very first thing that's going to happen is our module is going to check to make sure that pressure switch down here is indeed open before it starts the inducer. And so we're calling for heat at this point. It is checked to make sure that the switch is open. Now it energizes the inducer. The switch closes. It takes that and it can continue with the sequence of operation. During this time that we're seeing right here, this is the pre-purge period. We're getting all the dirty air out of the furnace and we're replenishing it with fresh air that is ready to be mixed with the gas and ignited. The very next thing we're going to get is an ignition sequence here. And we're going to open the gas valve and the igniter after a few seconds. So what you heard was an igniter sparking and the gas valve opening. We have established our flame, and so the furnace can continue to run. Now, after a few seconds delay, we will see our blower start up, and that is just a delay because we don't want to be blowing cold air on the occupant. And our blower has just came on. So we're going to be heating. Okay, we're going to drop the call for heating, and the very first thing that you're going to see is that the flame will immediately stop. Now, the inducer is still running and our blower is still running, and that's because we want to purge out all the dirty air out of our heat exchanger. That's why the inducer is running. The main blower is going to keep running because we want to keep cooling down the heat exchanger so it doesn't overheat and use up the remainder of the heat that we've created. As you can see, the inducer is finally slowing down. The board has dropped the signal to the inducer, and so the only thing left running on this furnace is the blower. After a few more seconds, the blower will also shut down. And you can hear the blower start to slow down because the board has dropped the output to it. And we once again go into a standby mode.